Today's episode is proudly sponsored by the Rising Tide Mastermind. Each and every year, the Rising Tide Mastermind gets together in Atlanta for a live event. This is one of the most anticipated events within the Rising Tide Mastermind. Normally, we have a Zoom call each and every week, but this is where we all come together and we become better friends. We learn more about each other and we help each other with their issues. It is my favorite thing, and I'm sure it is going to be your favorite thing to look forward to if you were a member of the Rising Tide Mastermind. That could be a possibility. To find out if the Rising Tide Mastermind is right for you and you are right for the Rising Tide Mastermind, go to scalinguph2o.com/mastermind and you can schedule a 15-minute call with me to find out more. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. I'm Trace Blackmore. I get the privilege of hosting this awesome podcast. And if you are listening to this podcast in the United States of America, we just celebrated Thanksgiving yesterday. Nation, this is my favorite holiday. I love cooking. I love having people over. I love just getting into the relationship with people, making sure that I honor something my grandfather taught me a while ago. And he said, at the end of the day, the only thing that matters are the relationships that we have. And Thanksgiving, I think, is just the quintessential holiday that highlights that. I know so many families get together and they bicker about politics or whatever is going on. Folks, none of that matters when it's all said and done. The only thing that does matter is what my grandfather taught me, and that's about your relationships. So that being said, I love Thanksgiving for that. We have a wayward Thanksgiving celebration is what we call it. We do Thanksgiving at our house most every year. And we invite anybody that we know that is not doing anything for Thanksgiving. Maybe they normally go visit some family and they haven't made plans this year or whatever's going on. We've had some people that have lost people in their family and they just don't want to do Thanksgiving. Well, we invite all of them to our house, and we have had quite a full house. But again, life is all about those relationships. So we did that again yesterday, had a great time. Of course, we normally play some games together. We played a werewolf game. If you've ever played Mafia, it's just like that, but with werewolves and villagers. It's one of my favorite team play games. I can't remember the actual name of that type of game, but you've got to convince people that you are or are not something that you are trying to play during that game. So anyway, look into Werewolf. You will love it. Played it with a whole bunch of people. We did that yesterday. We had a lot of fun with it. And folks, we've got a lot of leftovers. And of course, I think the turkey sandwich is probably the most popular meal on Friday after Thanksgiving. And of course, today is Black Friday. And they call it Black Friday because it takes this many days in the year for the average retailer to get in the black, which means they start making a profit after today. Well, how depressing is that? How are we ever going to get entrepreneurs into our economy when that's the information that we give? But I don't know if that's true or not. I guess every business is different, but it just goes to show you how much work goes into owning your own business. And let's face it, our economy is based on small business. The expression is small business is the backbone of our economy. Well, I do truly believe that. And there's so many small business owners that listen to this podcast. And if everybody knew what they knew years after starting their business, they probably wouldn't have started their business. I would have been terrified knowing what I know now and then trying to navigate that when I got into business 20 years ago. Oh my goodness. So I think there's definitely a benefit to learning things as you go, but I want you to know of a little known holiday. Tomorrow is Small Business Saturday. And this is where everybody is encouraged to go to a brick and mortar store. I guess there's also some online small businesses as well, but just think of all the things the brick and mortar businesses have to do. So I think it would be great if you can support them, but support small business tomorrow. I know people love those doorbuster sales that happen today. So do what you will with those. But if you can make most of your purchases to small business, I think that helps us all. And I just want to put a plug for small business and Small Business Saturday, which is November 30th, of course. Okay. And then on Tuesday is Giving Tuesday. And this is where you are encouraged to give to some cause. The cause that we support here with the Scaling Up H2O podcast is World Vision. So we're going to have some information for you on how you can support World Vision. Of course, we always promote the 6K that takes place in May every year. That's going to be no different this year. But if you're looking for something to support, we're all in the water industry, and World Vision is a great venue to support, a great organization to support, because their mission is to bring clean drinking water to everyone on the planet. Well, Nation, I want to talk to you about a few events that are coming up. And so many people learn about events that are happening through our podcast. On January 23rd and 24th, the 2025 Wastewater Administrators Conference is taking place in Frankenmuth, Michigan. So if you are a wastewater administrator, you definitely want to check this out. We will have information about that on our events page, as well as the Clean Tech Forum for North America. That's taking place January 27th through 29th. That's in San Diego, California. And this is 3 days of high quality meetings and deal making. And you can learn from analysts and other people within the industry about trends and innovations that are driving that sector forward. We'll, of course, have more information about that on our events page. And then if you are in Austin, Texas, January 27th through 29th, the Water for Texas 2025 conference is taking place. And this will bring together experts, innovators, influencers, and leaders discussing water issues from now and the years to come. Topics will include water science and technology, drought and flood, innovative solutions to change water, and Texas water policy. So if this is something that interests you, by all means, make sure you make arrangements to attend that. The American Chemical Society is having their Spring 2025 conference in San Diego, California, March 23rd through March 27th. There are so many people that listen to this podcast that are members of the American Chemical Society. So if you want to learn more about any of these conferences that I mentioned, well, that's such an easy thing to do. You can go to scalinguph2o.com, go over to our events page, and you can make all of your decisions from that page. And folks, as we're gearing up to end this year, it's such a great idea to start planning next year. Now, when you hear something today that's taking place in January, most likely you've already got plans in January, or you might have to rearrange your schedule. If you start planning months ahead, you can protect that time. And Nation, let me tell you, when you go to conferences and start learning and meeting people, things that you didn't know, people that you haven't met before, I think that is a real multiplier for your career because now you're getting all of these different sources of information that you might not have realized before. And if you're going to be in this industry, it's all about the information that you have, the people that you can call to help you out when you see something that you have never seen before. And a great way to start getting all of that under your belt is by going to conferences. I'm a huge fan of making time in your calendar and going to conferences. Nation, I'm also a big fan of the interview. And here is our next interview. My lab partner today is Steve Russell, process engineer for Kiewit. Steve, welcome to the Scaling Up H2O podcast.
Hello, how are you?
I'm doing great. I am really looking forward to talking about your paper that you gave at the most recent International Water Conference called Carbon Capture, Water Requirements, and Wastewater Treatments. Very sexy title. I don't know how you came up with that.
Yeah, you do what you have to, I guess.
Steve, before we go there, do you mind telling the Scaling Up Nation a bit about yourself?
Yes, I'm a process engineer at Kiewit. I'm primarily looking at water and wastewater in power plants and also in industrial settings. I also sometimes look at municipal water and wastewater. In terms of my personal life, probably the most notable recent thing is my youngest child, Kevin, just turned 18 recently. So I no longer legally have a child in my household anymore.
Did he actually move out?
No, he's still in high school, so it's just funny that now we all have adults in the house.
I've got an 18-year-old as well. Actually, he's turning 18, but yeah, he's still got another year of high school, so he's not going anywhere either.
Right. It's still nice having mom and dad around to help with things.
What are some hobbies you like?
I enjoy reading. Also, I'm involved with Boy Scouts. Both my son and daughter attend the Boy Scouts, so that keeps me busy. Other than that, it's just household chores and all that. It seems like that never ends.
What is the day in the life like for your career?
Day in the life, really, I'm pretty much an early riser. I've got a long commute, so I tend to try to avoid that a little bit. But I'm what they call a subject matter expert here at Kiewit. So I'm typically not involved that heavily in any one particular project. So I'm jumping around on different ones, providing assistance to less experienced engineers to either provide direct guidance or checking documents and drawings that they develop, answering miscellaneous questions either from the project team or from the field. So sometimes it feels like I'm on a game of Jeopardy where just getting questions left and right on all sorts of different topics. So it kind of keeps me on my toes.
So we're talking about power plants, and they put out a lot of carbon. And of course, we need to take that out of the discharge so it doesn't go out into the atmosphere. That ends up in the wastewater, and that's the subject of our conversation today.
Yes, mostly so. There's been a big emphasis on carbon dioxide being emitted, with power plants being one of the larger sources, and they've looked at trying to control that. So ultimately, they're taking that carbon dioxide out of the flue gas. The flue gas is what you get when you combust coal or natural gas. They're taking that out, and then it's a question of what they do with it at that point. They could compress it and go to like an underground cavern to store it, or perhaps use it industrially. So that has been a big focus in the industry. A lot of activity recently, but the general thought is that the water and wastewater portions can be figured out, but it's turning out they're a little bit more complex than maybe what you might think. And also, there's not a lot of resources out there. So it's kind of forced engineers like myself to really dig deep and see and find solutions.
So you decided that there wasn't enough information out there. You wanted to present a paper at the most recent International Water Conference. Tell us about that process.
Yes, I've learned a lot from conferences like IWC. It's been a great part of my career. I often get a lot of questions. It's just not practical for me to have direct experience on all the topics that come before me. So having resources like going to the conference papers, and things like that have been very helpful. So, I want to return the favor, and whenever I start running into something that I think would be of value to the community, to present on that. In this particular case, there's been a lot of activity at my company, Kiewit, on carbon capture, where most of the focus has been on the carbon capture side of things. What equipment do we need? How much does it cost? Those type of things. And so then they'll tack me onto the project and want to make sure we get all the water and wastewater figured out. So there hasn't been a lot of resources out there that provide a lot of guidance. So I've been having to use my experience in other areas of water and wastewater treatment and apply it to this application. So I thought it would be helpful to write a paper and do a presentation based on my experience. And so that's what I've done. Also, I'd like to note that I've had help from Eric Eisenbarth, who's a co-author of the paper. So he's a mechanical engineer that's more into the carbon capture and less into the water and wastewater. But he was able to help me write portions of the paper and edit and make sure that I was representing all the carbon capture correctly.
So the podcast is just audio. We don't have visuals. Can you describe what's happening so we're not discharging carbon into the atmosphere? What's actually happening underneath the stack, or at least the discharge of the stack? And then where does it go from there?
My paper is primarily focusing in on amine absorption technology. There are other ways of removing carbon dioxide from a flue gas, but essentially what happens is that you have coal or natural gas and you combust that. And so the carbon that was present in either one of those fuels turns into carbon dioxide, which we're trying to reduce the emissions. So they pass that through. It's really a 3-stage process, with the first stage being a quenching column. There's a lot of water in that flue gas, and it's warm. It's warmer than what we would like, so we cool it down in a quencher first, and then now a lot of that humidity comes back out of the flue gas. So that forms our flue gas condensate, which is a big part of what I discuss in this paper. Now, at that point, the flue gas is cooler, it doesn't have as much moisture in it, and we can pass it through an amine absorption tower, where they have a chemical, some type of amine, oftentimes a proprietary chemical or blend of chemicals, and it absorbs the carbon dioxide out of the flue gas into the amine. So now your flue gas no longer has carbon dioxide in it, at least as nearly as much as what it started off with. You can never get 100% removal, but you remove the vast majority of it. And so you can emit that flue gas out of the absorber into a stack typically. And now it's relatively free of carbon dioxide. But now you have that amine absorption fluid that is now loaded up with carbon dioxide. They call that rich amine because it's rich. It's got a lot of carbon dioxide in it. So now we pass that over into a regenerator tower. So now we're wanting to get the carbon dioxide out of the rich amine. And so that's done with like a thermal process, similar to a distillation tower, kind of heats it up, and the carbon dioxide evolves back out of the rich amine. And then now we're left with what's called lean amine, because now that amine no longer has as much CO2 in it. We can send that back to the regenerator. The CO2, carbon dioxide coming out of the regenerator, may need a little bit of treatment, most notably dehydration, depending on the use for the carbon dioxide, because it's going to be moist. It's going to have a lot of water vapor in it, and that can be bad for pipelines. So a lot of times they use a CO2 dehydration system, which may use like triethylene glycol to dry out the moisture from the carbon dioxide. And then also you would need to add compression, because it's going to be at a pretty low pressure. So typically you have a compressor or a series of compressor on that. So my paper really focuses in on what wastewater streams are generated in the process, most notably that flue gas condensate out of the quencher, that first step, as well as there's some other miscellaneous waste streams that had to be considered. along with the water demand. So one would be demineralized water that's needed for the process, and then also the process needs steam and cooling of some type that has to be managed.
Well, let's start with the wastewater discharge. You're talking to a bunch of industrial water treaters that listen to this podcast. What do you want them to know from your paper?
Well, the wastewater discharge is a bit tricky. There's really not a cookie cutter way of dealing with it. Each facility will be different in terms of the quantity and quality of the wastewater. The quality is going to depend mainly upon the fuel that you're using and how you're quenching the flue gas to get the flue gas condensate. So, unfortunately, there's not just a strict analysis that you can use and a strict treatment approach. So, as a process engineer, you need to really work with the project team and understand what that wastewater stream looks like. And my experience has been that the carbon capture vendors that are doing that whole carbon capture process are often not thinking in terms of what a water treatment engineer would think of. They're kind of thinking in terms of like gas properties. And so a lot of times they give you quality data that's not terribly useful in and of itself. And as an engineer, you have to take that and kind of convert it into something that's a little bit more useful. So a lot of times we're thinking like parts per million, milligrams per liter, that type of things. Whereas from the carbon capture vendor, you may get things like mole percent and other things. So you have to do some conversion in there to get to something that's helpful. Also, the carbon capture vendors will not really provide you much guidance on what to do with that wastewater stream, both in terms of treatment, recycle, disposal, discharge offsite, anything like that. And that's really where you need to have that expertise to go in and come up with the plan. As I mentioned earlier, the wastewater treatment's not trivial, but it's not the major part of a carbon capture facility. However, depending on the location of a site, maybe it's got limited water supply, maybe it has difficulty in discharging. It could start becoming a more moderate part of a project and drive it. The cooling needs and how that's handled can have a pretty major impact on the project, and also in terms of what kind of like cooling tower blowdown or other wastewater streams you're going to generate. So it's not as simple as just a process engineer jumping on a project at the end and figuring out the water treatment. Really need to have that engineer more nested into the project, because there's probably going to be several iterations and trying to figure out, what works best for the facility as a whole.
What would you say one of your biggest lessons learned has been in treating wastewater streams like this?
I think one of the things to really look at is the nature of the streams. It turns out that, like on the flue gas condensate, it's really varied from project to project. However, there's been some streams that you should expect to see, and maybe the project team doesn't focus in on that. And so, by understanding the process, you can kind of prime the pump to get that type of information and make sure that you understand it. Not only what are the flows, but are the flows continuous or intermittent? Do you need demin water for this type of service? So, like sometimes they do different rinses on the flue gas after the carbon dioxide's been removed. Are they doing that just with demineralized water? Are they doing that with acid? There's several different ways of doing that. So one of my lessons learned, it's good to have a broad understanding of water and wastewater treatment so you can apply that, but then it's also good to have the knowledge of the process, even if you're not the engineer that's responsible for the CO2 removal process. Being able to go in and work with the team and talk their language and get the information that you need, so you kind of have a really good comprehensive solution.
What are some of your favorite resources in learning more about this process?
Probably my biggest learning has been internally in Kiewit. Oftentimes, I'm not having too many conversations with those mechanical engineers. Usually, the project, if it's, say, something other than carbon capture, the water treatment can be done somewhat independently. Like if you're looking at a heat recovery steam generator, usually I wouldn't be working with that responsible engineer very closely. I might need a little bit of information. But here, I've been able to work with the engineers that we have that have been working with the carbon capture vendors, and I'm able to kind of get that kind of a pipeline for the knowledge that I need to work on the system. Also, there's been some questions about how do you permit these discharge, what level of treatment would you need to discharge it, and sometimes those answers aren't necessarily real easy. So we do have some people in the permitting group to work through that. Unfortunately, I don't think there is a document that tells you exactly how to handle wastewater from these systems, but then there are some EPA documents say that's related to the steam electric power generation, effluent limitation guidelines that may or may not apply. Even when you dig into those, it can be a little bit tricky. One of my experiences has been with flue gas desulfurization, which is another technology mainly for coal plants to remove sulfur instead of CO2. But having some of that knowledge there has helped to translate into some of the questions that we ask when we get into water, wastewater for carbon dioxide removal.
What's a question that you need answered at every single plant you visit?
Really, the big question is what wastewater streams am I going to get? What are the quality? And then what types of water do you need? Both demineralized water, cooling water. That's really the starting point. Then you get into project specifics. A lot of times the carbon capture is going into an existing facility. Not necessarily always, but that's been more the trend I've seen. So then understanding what the existing facility is doing. Do they have excess demineralized water that I can use? Do they have an existing discharge permit for their wastewater? If so, it'd be good to get familiar with that. Possibly we might be able to get our wastewater in there with the permit modification. And even if we can't, at least we kind of understand what issues they face with discharging their existing water. We might be able to apply that over to our system. What I'm a bit curious to see with these carbon capture projects is right now I'm mostly seeing feed type of studies, like conceptual type studies. I'm more curious to see what happens over the next several years when some of these will more than likely turn into full-blown projects and go from there. But, it would be really nice to do pilot studies. If an existing facility has the ability to do that, they would probably be focusing more on the piloting of the actual carbon capture system itself. But then if they do that, it sure would be nice to at least get some wastewater quality data to compare that against the theoretical. I haven't run into that in a project. A lot of times the feed studies are fairly quick, probably not set up to do, a full pilot in the time that that takes. But I'd be curious to see if we end up doing pilot type studies or the vendors do, if we could get some wastewater quality data along the way, that would be very helpful.
Steve, do you have any specific concerns when it involves carbon capture for wastewater?
Yeah, there's some things that you look at, and it's not always crystal clear if applying technology and knowledge from other industries really how well that applies. One of them would be suspended solids. So oftentimes the carbon capture vendor will give you a certain quantification of suspended solids, but they may label it as dust. When it comes to suspended solids removal, it's not only important about how much is there, like in parts per million or milligrams per liter, but also, what is the particle size? How well does it filter? Can you coagulate it? So, there are some assumptions we're making at this stage. If there's too much suspended solids, then we go with clarification first. That the suspended solids are lower, then you could go with filtration. But it also does raise a question. A lot of times the carbon capture vendors will be fairly conservative with their assumptions. And so they may be giving not to exceed values. And, you'd hate to go with a more exotic treatment system and find out later that you didn't really need it just because the vendor is being overly conservative. So, that certainly applies for suspended solids. But it's a little bit surprising to me initially. I usually think of burning natural gas, that's pretty clean. Coal, obviously, when you burn it, you get a lot of ash and whatnot. That's pretty obvious. But actually, with the burning of natural gas, you actually get a decent amount of what they call dust that you need to take care of in that flue gas condensate. And then if you have flue gas coming off of another source, like say a lime kiln or something like that, those suspended solids may even be different than if you were burning flue gas. So I'm a little bit curious to see how all that works out. We're doing the best we can based on applying our knowledge of clarification and filtration, but we could find out that either it filters better or worse than what we were hoping. Another area is nitrates. So within the flue gas, a lot of times you will generate some NOx. That's NO and NO2, I believe. And then once that gets into the quencher, it drops out as nitrites and nitrates. And then ultimately, if you discharge those, they can have an environmental impact that's not desirable. With flue gas desulfurization, like I mentioned earlier, the EPA recently published finalized rules on treating that water. And one of the items of concern is nitrates treatment in that water. But it's not crystal clear if and how that applies to flue gas condensate. With FGD, flue gas desulfurization wastewater, that water is considerably worse in quality, and there's a lot less likelihood of being able to reuse it. But with flue gas condensate, even though we may have some nitrates, we might still be able to use that in a cooling tower, depending on the project. But then now those nitrates are in the cooling tower blowdown. Nitrates are not easy to treat for. Typically, it would be a nitrification, maybe denitrification biological process. So, that's a little less attractive to a lot of industrial and power plant facilities who prefer more of a physical chemical treatment plan instead of biological. So, it could be depending on the discharge permit that they obtain that they may have to treat for nitrates. Another thing as well is that this water, typically the carbon capture condensate will typically have low levels or no hardness in it, which makes it a little bit interesting for treatment. A lot of times in water treatment and in cooling tower cycles of concentration type analysis, we're concerned about hardness. But here, a lot of times we're not going to have that. There are occasions where you will. So that makes the treatment scheme a little bit different. It could push us towards some newer technologies. An interesting one would be ultra high pressure RO, just because that allows you to further concentrate the liquid more than just conventional ROs. And since we don't have as much or any hardness in the stream, that might allow us to push it up there without getting into scaling concerns. So there are some things with the water and wastewater that we're seeing on these projects that may push us in directions that are maybe a little bit different than what we're used to for like a power or industrial facility.
Normally, when you write a paper, you learn things on the back end you wish you knew on the front end. Did that happen with you? And if so, what was that?
Yeah, I think probably one of the big learning exercises for me was just understanding the carbon capture process a little bit better. And Eric Eisenbarth was a great help there. Early on this work, I would get the wastewater streams and get some information. I'd ask for more information. Sometimes I get it, sometimes I wouldn't. But then, it's just a matter of treating that. We'd do a water mass balance and show where the streams were coming from and what treatment we were using and whether we were recycling or discharging them. So, I had an understanding from a water mass balance perspective, but I didn't really have as much appreciation for where these streams were coming from. So, gaining a better knowledge on the carbon capture system has been helpful, especially since there's just not resources out there, at least not many, where you can just do an internet search and find out exactly how you should treat a certain wastewater stream from the system. So then, if you're just dealing with the water analysis, I think you're a little bit of at a disadvantage over if you really understand that carbon capture system. Maybe there's some things that could be in that wastewater stream that the carbon capture vendor just didn't list. So that's a bit of an unknown. But if you understand the carbon capture system, then at least maybe you can bring it up and say, hey, well, I would anticipate this being in the wastewater stream. Is it in the wastewater stream? You can ask those type of questions. So that helped a lot. Also, probably the big one for me was the TEG wastewater stream. I had it in my mind that was somewhere else in the carbon capture system. Maybe the mean absorber or regeneration column, but that's actually outside. That's actually in the dehydration system once you've already gotten the CO2 out. So that's still considered part of the carbon capture system, but it's not with all the amine and all that. So that was helpful to get a better understanding.
If you could only stress one point to our listening audience today, what do you want that point to be?
All these projects are different. I was initially going into the paper hoping that I could maybe be a little bit more definitive on how to estimate what the different wastewater qualities would be and exactly what treatment would be needed. Unfortunately, there's just going to be a wide variety of these carbon capture systems, whether it's power plants, cement kilns, different industrial facilities. So I ended up structuring the paper more of here are some of the things you might run into or want to check. And if you have these in your water, here are some things that you might look into in terms of treatment. Here are some possibilities for recovering and recycling that you might want to consider. Here's some of the aspects on the cooling and how that might impact the whole water wastewater situation at the facility. So it's really almost a checklist. It's not, I didn't write it as a physical checklist, but if you're an engineer and you're new to this and you've been assigned to do water, wastewater for this type of facility, you could kind of go through, circle things, cross out things, and kind of at least get a good starting point so that you're real more efficient on the project.
The IWC process is probably the most intimidating when it comes to delivering papers because you have that reviewer that's agreeing or disagreeing with you. Can you tell us a little bit about that process and how you made it through?
Yeah, it's an interesting process. I do like it, not only for my paper, but when I'm reading other papers after the conference. Just kind of gives a little bit of perspective. Sometimes maybe there's some claims that are made in a paper that seem very dogmatic, but maybe need to be lightened up a little bit, or maybe a discusser might have some perspective that adds to the paper. For mine, interestingly enough, my discusser was Brad Beaker, who actually worked at Kiewit. We worked side by side for a few years. He's no longer with Kiewit, but so I knew Brad pretty well. So yeah, he brought up some good points throughout, and looking at the system and how it might apply. He asked several questions about some more of the details about the carbon capture system, which I kind of struggled with because I wanted to have enough information in on the carbon capture system and how it works to support a lot of the water and wastewater issues, but I didn't want to make it all about that. So it's a little bit glossed over in some parts, and he had some good comments. I was able to incorporate some, but not necessarily all. So I would encourage the reader, if you want to learn more about an amine absorption process, my paper is probably a really good high level introduction, but you probably want to dig a little bit more. But yeah, I've been a discusser on other papers in the past, and that's been good just because it's forced me to really dig deep into somebody's paper, and I've learned things just by being a discusser. So I would encourage, if you're going to write a paper for this, I would encourage you to not be intimidated by that process. People are pretty nice, and it can help balance out your paper. And also, if you can, be a discusser because it helps with IWC to have high quality papers and presentations. And also, you're going to learn more that way.
As a presenter, it's definitely the most intimidating process, but as an attendee, it's my favorite process for all the reasons you just mentioned.
Yes. I think I was a discusser before I was a presenter, so that's also a good pathway to kind of get in there. A discusser is maybe 3-4 pages ish when you write that, and maybe a 5 or 10 minute presentation. So just doing that is a good way to kind of get your feet wet. So when you get into writing a full paper, doing a full presentation, it's a little bit more of a natural transition.
We'll make sure to have your paper on our show notes page so people can log on to scalinguph2o.com and read into exactly what we were discussing today. I do have a few lightning round questions for you if you're ready for those.
Sure.
All right, my first question, if you had the ability to go back in time and talk to your former self on your first day as a chemical engineer, what advice would you give yourself?
I would say be flexible and organized. So, a lot of times going through college and then getting a job at a certain place and knowing what they do, you kind of have it in your mind what you're going to be doing. For me, I started out in the oil and gas field and was there for 2 or 3 years and then switched over to water treatment. So, in college and even coming out of college and starting my career, I had no idea I was going to be involved in water and wastewater. So now I'm 20 plus years experience just in water wastewater and only a couple of years and other things. So be flexible, kind of see what's needed both within your organization and industry. Things are changing. Carbon capture wasn't on, I don't think it was on anybody's radar when I started my career, and it's kind of been a little bit warm and cold here and there, and now it's pretty hot. So be ready to jump into things. Organized. I've developed a very extensive electronic file system that's very helpful. I find that a lot more helpful than just doing an internet search, at least going there first, where I keep stored articles, key drawings, and documents from different things. That's been very helpful and helps me to be more efficient. I think sometimes someone will ask a question and I'll come up with a relatively quick answer and they'll think I'm really smart. And it's like, well, no, I just happen to store the right file. Then my last thing is learn how to learn, especially within process engineering. There are occasions where you'll do the same process over and over and over again, but a lot of times you'll maybe just do one process, do another, and then you come back and do the first one. And project teams will give you some leeway to go out and spend some time and learn, but oftentimes there's just not a lot of room for that. Projects have budgets, they have to get done in a certain amount of time. So learning how to learn, how do I, in that context, do I go in and know what's important, what's not important, what to spend my time on, what issues should I bring back to the project team and say this is really a concern and we need to take a step back, and what issues can we make a high level assumption at this point and be safe. So just learning how to learn is a big thing. And also, sometimes when you'll get training from your company on things, and sometimes not. Sometimes they expect you to figure it out. So, just learn how to learn.
Great advice. Now, I normally ask, what are the last few books that you've read so I can bolster my reading list? But I understand that you have a reading bucket list. Can you tell us about that?
Yeah, one of the items I recently finished is I read a biography of the presidents, United States presidents, starting from Washington all the way up. I've read one of each president except for Biden and Trump, which I'm going to give them a little bit of time before, so somebody can write a good comprehensive book. But I read some books in between them. I didn't do it all one big marathon session, but it was very interesting. Not only did I learn about the presidents, but about United States and world history. I'm often asked, which president I like the best or whatnot. That's kind of a hard thing to answer, but probably the one that was the most pleasant surprise to me was John Quincy Adams. So he was president, and then after he served, he went back and was a representative for his time. He was pretty much a leader to abolish slavery in the House of Representatives, so he's a little bit ahead of his time on that. And then it was kind of interesting because people would bring him issues that even if he didn't agree with, he went and represented them, which is a little bit counterintuitive based on today's politics. So sometimes he would go in front of the House of Representatives and say, well, this isn't my opinion, but I've had several of my people in my state that have brought this to me, so I felt it was necessary for me to represent them.
Yeah, that's what a representative's supposed to do, right?
Yeah, I'll never be a politician. I know that much. So.
When Hollywood makes a movie about Steve Russell, who plays you?
Yeah, this is an interesting one. So I've been told that I look a little bit like Ralph, how do you say his Macchio from the Karate Kid?
Yeah.
So just a vague resemblance. We're about the same age as well. So I think you always pick somebody that looks a little bit better than you, but almost like you. So he'd probably be a good fit.
Do you have any karate skills?
No, I'm totally non athletic.
Can you wax a car and take the wax off a car? Paint the fence?
I can, but I'm kind of getting that point in life where I'm trying to minimize my chores. So
yeah, you got kids. That's what they're
yeah.
for.
So I'm not going to come over and help you with your fence.
Last question. If you could talk to anybody throughout history, who would it be with and why?
I would pick Nelson Mandela. I actually worked down in South Africa for over 3 years on a power project. And so while I was there, I got interested in South Africa and the culture. And, apartheid had ended in 1994. So it really wasn't that distant from, a big cultural change. So I was always really impressed with him. He spent several decades as a political prisoner, and then he became a president. And, you'd think most people would be very resentful and maybe try to divide the country and fix it that way. But he kind of took a different approach where he was able to really unite the country. And the way he did it was very interesting. I've read a lot of books about him, and, just be interesting to sit down and talk with him and really pick his brain on, what makes him tick.
Well, we really appreciate you coming on the Scaling Up H2O podcast and sharing much about a topic that we don't often talk about. And also, as a fellow father of an 18-year-old, we can create a support group or something afterwards. So thanks so much for coming on the Scaling Up H2O podcast.
Yeah, thank you. It's been a pleasure.
Nation, the IWC, the International Water Conference, got brought up a couple of times during this interview. And let me tell you, I had such a great time being the keynote speaker. It was right around this time last year. They treated me so well. I did not ask for a certain color dressing room and certain candies in the dressing room and no green M&Ms. There was nothing like that. And I don't think I could ever do that. I'm not that complicated. I'm a simple water treater. But they were just so generous to me. They made sure I had a seat up front. Of course, that was probably so I didn't hold up anybody as I was walking up to take the stage for the keynote. But they were just so nice and generous with their time. They really promoted this podcast because they knew that not only was that going to help the Scaling Up H2O podcast, it was also going to help them. And just a delight to work with. So for all the people that were on the leadership team at the International Water Conference for last year, thank you so much for how you treated me. It was a wonderful experience. And Nation, there's so many people out there that want to start presenting, to start doing public speaking. And it's one of my favorite things to do. And if it is something that you want to consider, all these conferences that we talk about in the beginning of the podcast, they all need technical speakers. They all need maybe non-technical speakers. So what's a topic that you feel comfortable speaking on? And maybe go ahead and put an abstract together and you might get selected. Episode 307 was when our friend Mike Solar, who's also on the leadership committee of the IWC, not only spoke about how to do a paper for the International Water Conference, he spoke about a complete process on how to do all technical papers. So be sure to check out episode 307 if that's something that interests you. And speaking of the IWC, we have a complete library of guests from the IWC. I just mentioned Mike Solar. He was on not too long ago where he talked about the treatment of aerospace machining and inspection water. So that was episode 383. We had episode 351 where Dr. Kelly Zier came on. She was talking about maximizing water's potential. And then we had episode 342, Beyond Compliance, Empowering Water Experts with In-Depth Electric, Steam, and Generation Efficiency Limitation Guidelines. And that was with Bill Kennedy. And then one of my favorite episodes is when I got to interview one of my water treatment heroes, and that was episode 339, Jane Kuchera. She did a reverse osmosis masterclass. And folks, let me tell you, when the expression comes around, she wrote the book on this topic. Well, she literally did write the book on this topic, and she did a fantastic overview and deep dive into all things reverse osmosis. We recorded that episode before I spoke at the International Water Conference, and then she brought a special copy that she had in her archives of her book, and then she signed it for me. And I got a great picture on the website of her presenting that with me. As I said, I could not have had a better time at the International Water Conference. It really made me want to speak at more conferences, and I've had the opportunity to do that several times throughout this year. And several people have reached out to me for next year. So I guess that means that they thought I was doing a good job with that. Nation, anytime you can get involved with a trade organization like the International Water Conference, like the AWT, the Association of Water Technologies, whatever it is, this is your platform to meet new people, to learn new things. Hey, that's the theme of today, I think. And somebody that's always helping us week after week, drop by drop, learn new things is our friend, James McDonald.
Welcome to Drop by Drop with James, the podcast segment where we wonder, explore, think about, imagine, and learn industrial water treatment, you guessed it, drop by drop, together. In today's episode, we're pondering something. We're pondering ppm, or parts per million. This could be a hard concept to grasp at times. So I find analogies to be very helpful to understand this expression of concentration. 1 minute in 2 years is a part per million. 1 inch in 16 miles is a part per million. 1 drop in 10 gallons is as well. 1 milligram in a liter is 1 part per million. 1 millimeter in a kilometer is 1 part per million. Did you know that 1 pound of anything dissolved in 1,000 gallons of water will give you 120 ppm? A 1% solution based upon weight is a 10,000 ppm solution. There are many more analogies out there, of course. Find the one that resonates the best with you. I'm James McDonald, and I want to encourage you to be like water by forming bonds with those around you, dissolving new knowledge, and making worthy ripples, drop by drop.
Thanks, James. And thank you, Scaling Up Nation, not only for listening to today's episode, but for celebrating small business. Tomorrow on Saturday, November 30th, that's going to be Small Business Saturday. And happy Thanksgiving. Of course, that just happened a couple of days ago. And Nation, if you are looking for a cause to donate to on Giving Tuesday, I highly recommend World Vision, and we're going to have information for you to do that on this podcast, on the show notes, on our social media. So don't worry about that. We will make that as simple as possible. In the meantime, I hope you are thankful for being in this industry. I know I am thankful that you listen to this podcast, that you share this podcast. And Nation, happy Thanksgiving. Have a great week, everybody. Ready to boost your water treatment expertise? Our Certified Water Technologist Prep course is designed to give you the confidence and skills you need to sign up for the Certified Water Technologist examination. Test your knowledge with our 100-question practice exam and learn what you need to succeed. Go to scalinguph2o.com/CWT prep to get started today.